The analysis of a pressure vessel using the static module in SolidWorks simulation is essential for evaluating its structural integrity under internal pressure and external loads. The process begins with the preparation of a 3D CAD model, incorporating key components such as the cylindrical shell, hemispherical or elliptical end caps, nozzles, and supports. Material properties, including Young's modulus, Poisson's ratio, and yield strength, are assigned based on design requirements, typically using carbon steel or stainless steel. To ensure accurate results, a finite element mesh is generated, balancing computational efficiency and precision. Tetrahedral or hexahedral elements are commonly used, with mesh refinement applied at critical stress concentration areas, such as welded joints and nozzle connections. Once meshing is complete, boundary conditions and loads are defined. A uniform internal pressure is applied to simulate operational conditions, while external constraints are set at base supports or mounting points to prevent unrealistic movement. Additional loads, such as external forces, self-weight, and thermal effects, may also be considered depending on the application. Using the static module, the simulation is executed to compute stress, strain, and displacement results. The von Mises stress distribution is analyzed to identify high-stress regions, ensuring that the maximum stress values remain within the material's allowable stress limits as defined by industry standards such as ASME BPVC. Displacement results help assess whether excessive deformation could lead to operational failure, while the factor of safety, FOS, is evaluated to confirm the vessel's reliability under the given loading conditions. If the analysis indicates that stress levels exceed allowable limits, design modifications such as increasing wall thickness, adding reinforced supports, or selecting a different material may be necessary. The simulation is then repeated with the updated design parameters until the structure meets safety and performance criteria. By leveraging SolidWorks Simulation's static module, engineers can efficiently analyze and optimize the pressure vessel's design, ensuring structural integrity, compliance with industry standards, and overall reliability before manufacturing. This simulation-driven approach not only enhances design confidence, but also helps in reducing material costs and optimizing manufacturing processes by ensuring an efficient design from the start. By identifying potential failure points early in the design phase, engineers can implement necessary reinforcements, improving the longevity and safety of the pressure vessel. SolidWorks Simulation provides an intuitive interface and powerful analytical tools that enable engineers to validate their designs without the need for costly physical prototypes. With accurate results and industry-standard compliance, this method is invaluable for engineers working in pressure vessel design and analysis. For more insights into CAD modeling, FEA, and engineering simulations, visit Blueprint Bazaar, where we explore advanced engineering solutions